Students taking the AIME should be familiar with the floor function. If you need more experience, get a copy of AOPS Intermediate Algebra and take a look at Chapter 16. There's a lot of practice problems here. Every number can be written as the sum of the floor of that number plus its fractional part. To make it easier, we're going to let A be the floor of x, and R is going to be the fractional part of x. A here is an integer, and R is between 0 and 1. So instead, x is equal to a plus r. In the problem statement, we have n is equal to x times the floor of x. So we'll substitute and distribute. And we're looking for n in this interval. Since x is positive, we have that the floor is going to be greater than or equal to 0. So let's start with a equals 0. Substituting into this equation, we have n equals 0, but we need to n to be greater than 0. So there's no valid solution here. Let's try a equals 1. Substituting, n is going to be 1 plus r. Since r is between 0 and 1, we'll add 1 to this chain inequality. So n is between 0 and 2. We also have that n is an integer. So for a equals 1, we're looking for all integers between 0 and 2. We have one solution where n is equal to 1. This occurs when r is equal to 0. So this is our first solution for n. And we'll go on to a equals 2. Substituting, we have n is equal to 4 plus 2r. If we again start with r between 0 and 1, if we multiply this through by 2 and add 4, we get this n is between 4 and 6. And again, n is an integer, so we're looking for all the integers in this interval. That's 4 and 5. This occurs when r is equal to 0, and we get 5 when r is equal to a half. So we have two more valid solutions here for n. Let's try again with a equals 3. Substituting up here, n is equal to 9 plus 3r. We'll take our r in the interval from 0 to 1, multiply through by 3 and add 9. So we have 9 plus 3r is between 12 and 9, and it's an integer. So we have n is equal to 9, 10, or 11, when r is equal to 0, 1/3, or 2/3, giving us 3 more solutions. Now we can generalize for n equals a squared plus ar, where r is between 0 and 1. Multiplying this chain inequality by a and adding a squared, we have that n is in this interval. The number of integers in this interval we can find by subtracting this upper bound and the lower bound. We'll take a squared plus a and subtract a squared. So indeed, we have a solutions for our value of a. We're counting up all values of n, so that's less than 1,000. So we want a squared plus ar is less than 1,000. Note that a times a plus r is less than a times a plus 1, since r is less than 1. And we want this to be less than 1,000. So let's find the largest value of a such that this is true. When a is equal to 31, we have 31 times 32 is less than 1,000. For the next value of a, our product pair is 32 times 33, and that's too big. So we'll be counting all n for a less than or equal to 31. Starting with a equals 1 and a equals 2 all the way up to a equals 31. This is the sum of consecutive integers, so we'll use our formula, and our answer is 496. If you'd like me to solve any other math contest problems, please leave them in the comments.